Okay guys, so we're going to finish out section 6B about standard deviation. So this is video, it's the part 3 of the 3 videos that I'm going to have for you now about section 6B. So this part is going to include everything you need to know about standard deviation. So to start off with, standard deviation is actually a number that statisticians like to use. It's a commonly used number, as you can see here, that describes a variation. And so we saw that in the previous section that you can use a 5-number survey to describe 5 numbers about the data, but statisticians, people that deal with statistics, often want just a single number to use to describe the variation. And so that's what we're going to do here with the standard deviation. It is that single number that's most commonly used to describe the variation. Okay. All right, so the standard deviation is found by following these steps. Looks a little complicated, but we're going to go one step at a time. So basically, you're going to find how your data deviates from the mean. You're going to square that, because here you see we're going to be following our order of operations within this formula. So we're going to find what's in the parentheses. We're going to find our deviation from the mean. We're going to square it for each one of those. Then we're going to sum them together, divide by how many data values there are, subtract 1, and then take the square root of that answer. So we're just working our way out through the order of operations, okay? So just hang in there, and we're going to get this. All right, so our standard deviation is found, and here are the words that go with what I was just sharing with you. You're going to first off find your mean of your data. You're going to see how your numbers deviate from your mean. Then you're going to square those deviations, sum those squares, or add all those squares together, divide this sum by the total number of values minus 1, and then the standard deviation will be the square root of this quotient that you get once you do that division. Okay, so if you need to pause along the video anyway, at any point to catch up, go ahead and do so. I'm just going to keep moving on. Just pause if it's a little too quick for you. Okay, so we're going to start off with, we're going to calculate our standard deviation by hand. So to calculate your standard deviations for the waiting time at the big bank or the best bank, you're going to take your set of values, and these are the same examples we used in the previous videos. So for the best bank, or excuse me, the big bank, we're going to start off with by computing the mean of each of these sets of data. So the mean of the big bank comes from adding them all together, which you get 79.2, and then dividing by 11. When you do that, you get 7.2. And for the best bank, you do the same thing. You add all the values together and divide by 11, so you get 7.2. So now we have the mean for the big bank, and we have the mean for the best bank. So that is step 1A. So you can see here in our checklist, there's our first step. We found our mean. Okay, the next thing we need to do is we need to find the squares of all the deviations from the mean. Now, deviation is just how it changes, or how it is comparing back to it. So is it above it, is it below it, and how far away is it? Okay, and so what we're going to do is we're going to see how these numbers deviate. So we're going to ask ourselves, how does 4.1 deviate from 7.2? And how does 5.2 deviate from 7.2? And how does 5.6 deviate from 7.2? And so on. And then we're going to do the same thing with the best bank. So one easy way to do this is to kind of put it in a table format. If you're familiar with how to use Excel, you can do spreadsheets and other things to do this as well. But we're just going to make a table and do this by hand. So when you go to your next table, this looks a little crazy at first, but we're just going to take this one piece at a time. Okay, in fact, I'm just going to take a piece of paper and kind of cover up some of what's going on here so it doesn't overwhelm you a little bit here. So first off in your table, step 1A is right here. Step 1A is to take all your numbers that were from that previous data set for the big bank, and we're going to add those all together and divide by 11, and we get our mean, which we did on our previous page. Okay, so we just added all those up. Let me just double check there. When we added those up, we got 79.2. There we go. So we got 79.2, and we divided by 11, and we got our 7.2. So there's our first step. Then the next thing you're going to do is you're going to take each one of those numbers right here, and you're going to see how far they are away from that mean. So you're going to take, like this first one here, you're going to take 4.1, and you're going to see how far it is away from 7.2 by subtracting them. So you're going to do 4.1 minus 7.2, and you see that 4.1 is actually 3.1 below 7.2, which is why we list it as a negative. And then you're going to continue down your table doing the same thing. Okay, you're going to list, I'm just going to trying to keep those numbers from scaring you guys, just covering up a little bit. So then you're going to take the 5.2 and you're going to subtract the mean, and you get negative 2.0. And then you're going to continue on and do that with each one of these values in the table. So you're going to work your way down with subtraction and find all the differences between the time and the mean. Okay, so if you need to pause the video, I want you to pause and go ahead and fill the rest of that table in. Once you get it filled in, I want you to unpause and check with the ones I have right here. Okay, now we're going to come over here to the last table now once you have those checked, or the last side of the table, the last little column. And so we have the deviation is going to be squared. That's our step 3. So if you go back to our checklist, cover that back over here. I'll pull that back over here. So we already computed the mean. We already found the deviation from the mean. Now we're going into step 2, which is to find the squares of all the deviations. So we're going to take each of these numbers that we just found in this previous column, and we're going to square them. So we're going to take negative 3.1 and we're going to square it. And that makes 9.61. Now please be careful here. That is actually in parentheses because it means negative 3.1 times negative 3.1, which actually will go back positive. Okay, so you're going to make that a positive 9.61. And you're going to continue on down your table, and you're going to square all of your deviations. So you can see here this one was negative 1.6, so we're going to square negative 1.6 and get this 2.56. And you're going to continue. So if you want to go ahead and pause and try to fill in that column as well, and then when you unpause you can check. So when you get finished filling in your table, this is what you should have on this third column. So there's step 2. We found our squares of all the deviations. So we can come over here and we can check off step 2. Okay, step 3 is to add all the squares of the deviations from the mean. So we're going to add all the squares. So we're going to take and we're going to add all these values right here together. If you do that correctly, step 3, right here I'm going to highlight that. Step 3 is when you add them all up, and they should sum to 38.46 if you've done all of them correctly. Okay, so reviewing real quick what we've done, we found our mean, we found our deviation by subtracting our values and the mean, then we squared our deviations, and we took those values after we squared them, and we got a sum of those deviations. So that's steps 1, 2, and 3. Okay, step 4. On step 4, you're going to, it says right here, divide this sum by the total number of data values minus 1. Okay, so we're going to take this 38.46 and we're going to divide it by 11 minus 1 because we have 11 data values. So we're going to do 11 minus 1 here. And that's going to mean we're going to be doing 38.46 divided by 10, which makes 3.846. Okay, so we've got this 3.846 right now. And we're going to take that 3.846 and we're going to bring it down here to work out step 5. Okay, so we did step 4. Step 5 is to find our standard deviation. We just take the square root of that quotient. Okay, and remember, quotient means division. So what we got here, this 3.846 is called a quotient. So we take that 3.846 and we just take the square root of it. And of course you can use your calculator to help you out there, and you get 1.96 minutes. Okay, so what we found here is that the deviation, the standard deviation for the first set of values for Big Bank is 1.97 minutes. So this right here, there's our standard deviation, 1.96 minutes. Now you're going to follow the same process for Big Bank. Okay, for Big Bank you're going to come down here and you're going, we've already got our mean, then you're going to subtract it, get your values, then you're going to square those deviations. Okay, if you do this correctly, you notice that I already have the sum of those deviations right here. They should sum to 1.98 in step 3 if you get these right. So if you get to this point and this is not 1.98, you need to go back and check your math here. Okay, so there's your step 3. Once you have that, you'll go on to step 4, which is where you'll take that 1.98, you'll divide it by 11 minus 1. You should get 0.198. And you'll take the square root of that 0.198, and you'll find that your standard deviation for best bank is 0.44 minutes. Okay, so just double check those as you go and make sure you come up with these values. Then we're going to come on over here, and when you have those finished, you see that you have 1.96 and you have 0.44. 1.96 is a greater value than 0.44, which, as we expected from looking at our box plot in the previous section, means that the waiting times show greater variation at the big bank, because this 1.96, if we go back here, this 1.96 goes with big bank. Okay, so our big bank has a greater variation than our best bank. All right, which we could tell earlier again. Like we said, we could tell that from the plots that we made before. This one is spread out a lot more. We can see that variation in that visually. Okay, so then the last thing you're going to do down here is you're going to make this from the beginning. You're going to do this on your own. There's no table given to you, but you're going to take your set of values. You can draw your own table. This gets kind of complicated drawing it yourself on here. What I would recommend is that you just go over and go to a piece of notebook paper and draw this in. Okay, so I've actually started myself one over here on a piece of notebook paper for this set of data. Okay, and so I wrote my score, my deviation, and my deviation squared column. Okay, then if you list all your scores, and this time they don't really have to be in order from least to greatest, because we're just finding the differences here and we're summing them together. It's going to work out either way. So your first step is to add all these together. Okay, and so I have worked out part of this for you right here for you to know what these values should be. So if you want to pause and try a little bit of this on your own and then check, you may do so. Okay, so I'm going to come down here and I'm going to go ahead and show you that in step 1, if you do this correctly, you should get a total of 814 when you sum those together, and then you divide that by 11. So in step 1, you should get your mean to be 74. And then you're going to take that 74, and that's what you're going to use here for all your standard deviations. Okay, you're going to do 58 minus 74. That's a negative 16. Then you're going to do 67 minus 74, which is a negative 7, and so on, all the way down. Okay, now once you've done all of those, your next thing you're supposed to do is square your deviation. So you have all your deviations completed, then you're going to come over here and you're going to square them. So you're going to do negative 16 squared. It's going to make 256. And then you're going to do negative 7 squared. It's going to make 49, and so on. You're going to work out all those deviations. So again, you can pause at any point and try those on your own. So here's our step 3. When you get those, if you get those done correctly, then the sum, when you add them together, should come out to 1,796. So there's your another checkpoint to make sure you're working these correctly. If you get to this point and you do not have 1796, you know you need to check your math back through here. So that should be 1796. That's step 3. Okay, step 4, you're going to take that 1796 that you just got from the sum of your deviation squared. You're going to divide it by 11 minus 1, which is 179.6. And then for step 5, you're going to take the square root of that 179.6, and you get 13.4. And so our standard deviation for this set of data is 13.4. Okay, so just do your math very carefully and just make sure you double check as you go. Thank you.